Before we look at exactly how transformers work, let's very quickly recap how they're used in the national grid. Most of our electricity here in the UK is generated at huge power stations, which are spread out all across the country. Once they've generated the electricity, it has to be passed through step-up transformers, which increase the voltage to around 400,000 volts. The purpose of this is to minimize energy losses as the electricity is sent across the country in a huge network of wires and pylons. Then once it gets to where it needs to go, like a small town, it passes through a step-down transformer, which decreases the voltage to around 230 volts, so that it's safe to use in our houses. So to sum up, the role of a transformer is to increase or decrease the voltage of electricity. To see how they do this, let's take a look at a single transformer. The grey stuff is a chunk of iron, which we call an iron core, and it connects the primary coil on the left to the secondary coil on the right. Now, how they work is kind of confusing at first, and in the exam you're going to have to be able to use the correct terms properly, or you won't get the marks. So just bear with me as I explain it, but you might have to rewatch this bit a couple of times. The way we're going to approach it is to consider what happens to each part of the transformer step by step. The first thing to happen is that an alternating potential difference is applied across the primary coil, which causes a current to flow, and generates a magnetic field around the coil. Because the potential difference is alternating though, the direction of the current, and thus the magnetic field, will also alternate. Next, this alternating magnetic field in the primary coil induces an alternating magnetic field in the iron core. Because remember, iron is a magnetic material, so it can become magnetized if it's exposed to a magnetic field. Lastly, the iron core's magnetic field induces a potential difference across the secondary coil. And if it's part of a complete circuit, which it will be in a transformer, then this causes current to flow around that secondary coil. So to summarize all of this, the transformer is effectively just transferring the current from the primary coil over to the secondary coil. But instead of the electricity just conducting straight across, it uses these induced magnetic fields. And the reason it can't just pass straight across is because the wires are insulated in plastic, so the electricity can't pass between the wire and the iron core. Now, the reason that we have to use all of this weird magnetic stuff is because it allows us to change the size of the potential difference. For example, in this one, which is a step-up transformer, if we put a 10-volt supply in, we'd get a 20-volt supply out. This is because there are twice as many turns in the secondary coil as there are in the primary coil, so our voltage gets doubled. In contrast, this transformer will step the voltage down, because there are fewer turns on the secondary coil than there are on the first.